Hi everyone, welcome to Electronics with Professor Mughal. I am super excited and this is going to be a very special video, and the reason I say that, as you can see, my daughter is with me, right? What's your name? Isel? Great. She wanted to be a part of video and I thought maybe she could help me with the introduction of today's video, and this is gonna be a very similar project to what we did couple of weeks ago, scrolling numbers. This is gonna be scrolling messages. If you ever been on Times Square in New York, you see all those scrolling billboards. Today we are going to make exactly like that. So what are we doing, Isel? Today we are creating and designing a scrolling message onto an FPGA board, right? Alrighty, so without wasting much time, let's get started. So when you would implement the code onto the FPGA board, by default it's going to display high, and that's what I have set it to actually. So notice over here there's a middle button. I can reset the message. It displays high, and then every 1 second each of the character being displayed is going to shift to the left. Every 1 second it's going to shift to the left, and that's what it's basically doing. I'm trying to display something as simple as high here, and as I would show you how to set logic like this, you should be easily be able to customize it and display something bigger, like open or close, or welcome message or something like that. So it's pretty simple. There are no inputs. As soon as you plug in, the board will display the message. In this case it's high, and you can press the center button to reset the message, which is basically it's going to display high and then start scrolling to the left every 1 second. Now that you guys have seen the demo, I want to start off with the functional block diagram and then move on to the coding part. The functional block diagram for the scrolling message FPGA project is pretty simple. I got the slow clock right here, which is a 1 Hz clock. Like I said, the characters, they move to the left every 1 second. And then I also have a slow clock, which is another slow clock, 100 Hz. This is for the toggling 4 7-segment display I have. So notice on the top, on the right part of your screen, when you implement the code, it's going to display high with 2 hyphens on each side. Okay, so I'm going to create a counter which I'm gonna name scroll, and this is going to be a 3-bit counter, because if you look at the sequence, it's actually going from 0 to 7. What's happening by default at the beginning, it's going to display high, and then this hyphen is going to shift to the left, means it's gonna appear over here, and this H is gonna move over here, this I is gonna move over here, and this hyphen right here is gonna move over here, and it's gonna keep on rotating to the left every 1 second. And if you look at right here, when the scroll counter that we are going to create, it reaches 4, we are basically going back to how it was by default, right? So, and again, it just keep doing it in a loop. And that's what we're gonna do when we do the coding. We will have this thing stuck in a loop, that every time it reaches this right here, it keeps on doing it, shifting to the left. The top module over here, which I'm gonna name as scrolling message module, most of the coding is going to be inside this module right here. I also have another module which is BCD to 7 segments. So we are displaying these characters, and so we have H, we have I, we have hyphen, or dash, whatever you want to call it. That is going to be BCD to 7 segment. And then finally the output of this module is going to be the 7 segments and the 4 enable. Remember, we are going to enable 1 segment at a time. I've done plenty of videos on it, so I'm not going to spend too much time, but enough to cover to understand what's going on. Now that you have a good understanding of the functional block diagram and you have seen the demo, and this is just another graphical description of how things would look, let's move on to the coding part right here. Now I have done most of the coding just like I usually do in most of my videos. Just to save time, I want to keep these videos short, because if I do the coding real time, my videos are an hour long, an hour 30 minutes, and nobody watches those videos. So I want to keep it, 10-15 minutes, and you guys can get most out of it. So like I said, there are a total of 4 modules including top module. I want to start off with the BCD7 segment over here. So starting off here, line number 1, line number 2 and 3 are basically my IO ports. We have a 4-bit input, which I named as Y. We have 7 segments, so there's a 6-bit register which I labeled as display. Just using simply the always at command, we're looking at Y, and we're looking at only 3 cases because we only have 3 possibilities: dash, H, and I. I'm gonna have my H and I both in uppercase. If Y equals to 0, then the segment, which is basically display, is going to get 7 bar B. What it is basically, all the segments A, B, C, all the way to F are going to be off, and the segment G right here is going to be on. This is the segment which is basically this dash right here in a 7 segment, right? And because it's active low, so 0 means on, and therefore I have 0 over here. Similarly, if I need to display H, if Y is 1, then display H. H in uppercase would make this combination right here. Again, segment A is going to be off, segment B and C are going to be on, segment D is going to be off, E, F, and G segments are going to be on. And I is basically pretty simple. You can either have B or C segments on, or you can have E and F segments on. It's up to you, whichever way you want to display I. Following it by N case, and then this N is basically for this big N right here. And lastly, you have the N module. So this was pretty simple BCD7 segment module. I'm going to move on to slow clock now. I got 2 of those, 1 Hertz and 100 Hertz. There's only one difference between the 2, and that is of the counter right here. Now, I got this input and output ports over here. Input is clock in. This is basically the FPGA board clock coming in, which is 100 megahertz for Basys 3 board I have. And then this is going to be a 1 Hertz clock. So I need to cut down this 100 megahertz into 1 second 1 Hertz clock. You don't necessarily need 56 here. 28 I believe should be enough, as long as this number is big enough that you can count up to 49 million. You should be fine. Now what's happening over here, we have created a register which initially the value is set to 0. Okay, we are going to use an always at block whenever the positive edge of the original clock arrives, which is the 100 megahertz clock. We're going to look for the period count. If the period count value has not reached this value, which is 49 million, initially it's 0. And if the period is not equal to 49,999,999 million, then period count should go up by 1. Okay, and clock is set to 0. If that's not the case, if the period count is 49,999,999, that means half a second has elapsed, and the period count should reset itself back to 0, and the clock should go to 1. Okay, so for half a second clock is 0, and for the other half a second clock is 1. And in a 1 complete signal contains a 0 and the 1, and the total time period is 1 second, and hence this is a 1 Hertz clock right here. This is the magic number right here. And how did I get this 50 million count right here? Well, we are trying to go from 100 megahertz to 1 Hertz over here, right? So 100 million hertz and hertz will cancel out. 100 million divided by 1 is going to be just some 100 million clock cycles right here. 100 million clock cycles, and you know, in one clock cycle, half of the clock cycle is 0, the other half is 1. So we are basically looking at 50 million clock cycles, and therefore this is where we get 50 million over here. And it'll count from 0 to 49 999 because that makes 50 million, right? Similarly, when we move to the slow clock 100 hertz, everything is similar except for this number right here. How did I get this 500,000? Well, we're trying to get 100 megahertz frequency to 100 hertz. 100 hertz and 100 hertz will cancel out, hertz and hertz will cancel out. So you basically get 1 million clock cycles, right? Half of that is going to be 0, and half of it is going to be 1. So half of 1 million is going to be 50 million. Basically 500,000, right? 500,000. And if I'm saying 500,000 minus 1, what it means, it's basically a start counting from 0 and goes all the way to 499.99, right? So 0 to 499.99, that makes 500,000 cycles, and that's what we want, right? Okay, and then if it has not reached this count, it goes up by 1, clock is set to 0. If the period count is equals this number right here, then period count should go to 0. It should reset itself and the clock should get 1. So for 500,000 cycles it's 0, for 500,000 cycles it's 1. These two combined make up a clock of 100 hertz, basically 10 milliseconds. Let's move to the scrolling message. This is the top module here, folks. I got everything commented, so it should be fairly easy to understand. And those of you who have watched my last video, this is comparatively an easy to understand code. So I got my Basys 3 clock right here. I got the reset button, and I got the 7 segment and the 4 enablers, all defined as IO ports. I got my 2 clocks declared as wires. One is the 1 second clock, the other one is a 10 millisecond clock. This 10 millisecond clock is for toggling all 4 segments on the Basys 3 port. Remember that? Okay, now comes line number 32, scrolling message. Remember, I was going to show you that we are going to have a scrolling counter right here. It will count. So because we were counting 0 to 7, well, not necessarily need to go down to 7. We can actually go from 0 to 4 because 4 is what we have at 0. So we can have a loop that anytime it hits 4, it basically goes to 1, because when it reaches 4 right here, which is hyphen H I hyphen, H is going to go here and this hyphen is going to show up over here. So everything is going to lift to the left, shift to the left, which is basically this one right here, correct? So therefore I have the 3-bit scroll right here. This is for the scrolling the message. Here the 4th is the leftmost segment and the 1st is the rightmost segment of the Basys 3 board. Remember that you got 4 7-segment display on the Basys 3 board. I've labeled them as 4th, 3rd, 2nd, and 1st. 4th is the one which is the leftmost segment, and the 1st is the rightmost 7-segment display on the Basys 3 board. It can display anywhere 0 to F, so I got these 4 bits right here declared as registered. Similarly, what we are going to display is H, I, and hyphen. So I got my 4-bit. This is something that is going to be going on to these segments over here. So again, this needs to match. Therefore, we have 4 bits here as well. Over here, line 39 and 40, basically instantiating the 2 modules that I have over here. Make sure this clock, you have to go by the same order. So if you go to my clock code here, I got my input first, then comes the output. So I'm following the same sequence over here. I define my input here, which is clock, and the output is the slow clock 100 hertz, which I have declared as a wire on line 31. Same thing with line number 40 as well. Let's move to line number 42. Scrolling the letters on Basys 3 board. Okay, alrighty. So here comes that part that I was showing you over here. Let's do the scrolling part now. If reset, scroll should get to 0. If reset, the scroll should get to 0. It means it should display -hi hyphen. Else, if scroll gets to 4, if scroll gets to 4, which is basically -hi hyphen, it needs to go to scroll 1, scroll count 1, because from here, anything that shift to the left, it's going to look like this, what I have at 1, right? So therefore, I have else if scroll equals to 4, then scroll gets 1, else keep on incrementing by 1. So that's a very simple part. It's a little tricky, but it's very simple, you know. Now let's see what is going on over here, this part of the code right here. Well, this part of the code is responsible for what is being displayed on each of these segments. Okay, let's go back to that graphic again. Remember, this is the first, this is the second, this is the third, this is the fourth segment. So from right going towards left, first, second, third, and fourth. So initially we want to display -i h hyphen. So that's what I have over here. Always at block, looking at the slow clock, because we want this to rotate to left every 1 second. So therefore, I'm using a slow clock, 1 Hz clock. Begin, and then you're gonna use bunch of case statements for the scroll. When the scroll is 0, it should display -hi hyphen. Okay, -hi hyphen. Okay. Basically, this dash is a hyphen over here. You can use you can say whatever you like, but I think I have it written down as dash. So dash hi dash. So the fourth segment is going to display dash, third segment is going to display h, second segment is going to display I, first segment is going to display dash again. And what is this 2 doing over here? What do you mean by saying 2? Well, remember when we did the coding for BCD7 segment, 2 was I, 1 was H, and 0 represents a dash. Okay, so remember that you can change that around if you like, but that's how I have gone with. Similarly, if the scroll count is 2, oh not 2, 1. If it's 1, let's see how it looks like at 1. hi dash dash. So let's look. hi dash dash. Similarly, when a scroll is 2, I dash dash h. So I have I dash dash h over here. So that's how it's going to work for all the cases. Remember, we are only going to going to look at the 4 cases. We're not going to look at 5, 6, and 7. Why 4? Because if you look at the 4, it is pretty similar to 0. So whenever it reaches 4, we are sending it back to 1. And that's what this part of the code was doing, right? Anytime it reaches 4, we're going to send it back to 1, and it'll keep on incrementing by 1. So it gets stuck in a loop. Okay, what is this part of the code doing over here? This part of the code is responsible for toggling the 7 segment display 1 by 1, and then making sure that the right character goes on the segment. But in order to do that, we are going to create a counter. Okay, so that's a 2-bit counter because we only got 4 segments. We got 4 segments over here, 1, 2, 3, 4. So we need a 2-bit counter. And then when the reset button is pressed, the counter goes to 0, else it keeps on incrementing by 1. So we're gonna look at the count, but we're gonna go through a bunch of case statement because it's a 2-bit counter. So basically we have 4 cases. If the count, this is acting as a decoder actually. So if the count is 0, 0, if the count is 0, 0, then this LED should light up. This should be on and it should display hyphen. Okay, let's see what's going on. If 2 bar B00, if counter is 0, then D is going to display first, and you know that what is first? First is whatever is the scroll count is, and it's going to display whatever the character needs to be, okay, depending upon the scroll count at the same time. You got two counters going on at the same time, right? So D equals to first, and enable is going to be 1110. Why 1110? Because we want dash to be displayed here, so this is going to be on. Okay, again, like I said, I'm not going to go through BCD 7 segment module because we have done it many times. But what's happening when this segment is on, the other three are off. And when this segment is on, the other three are off. Then this segment is on, the other three are off. When this segment is on, these three segments are going to be off. And it's all happening at 100 Hertz. That's what this clock is doing. This is happening 10 milliseconds. This stays on for 10 milliseconds, then goes off. This stays on for 10 milliseconds. Everything else stays off. And then so on. When this is on for 10 milliseconds, the other three are off. So it's basically toggling, okay? So this is what's happening. You have got to have these two statements within begin and end, because you are basically giving a value to those two variables. If anytime you give a variable or assign a value to two variables, you have to make sure you have a begin and end. When the counter goes up by 1, that means this segment is going to be off. Now this segment is going to be on, and the other three are basically off, right? And what do you want to display over here? Whatever is the second. Remember, this is first, second, third, fourth. So D is going to be second, and enable is going to be 1101. 4 bar B basically means we got 4 bits. Segment 4 is going to be off, segment 3 is going to be off, segment 2 is going to be on, and segment 1 is going to be off. And similarly, we have the rest of the coding for the other two. If you look at 2 bar B1, when the count reaches 1, that means this LED 7 segment needs to be on, the other 3 going to be off, and this should display whatever is the fourth character. And so D equals to fourth here, and enable is equals to the leftmost segment is going to be on, the other 3 are going to be off. This being active low, 0 means on, remember that. Followed by the end case, and then we have the end statement for this begin right over here. Okay, we are almost done with the coding part. Line number 34, this is basically instantiating BCD 7 segment, this code right over here. And then what goes inside is the input, basically, which is D here, and then the output segment, followed by the end module. The constant file is pretty simple. We have a reset button over here. This is the center button. We have a clock, the Basys 3 clock, the original clock. You have the 7 segment and the 4 enablers right here. I have already, if you, maybe I can do this also. I'm going to, I got everything saved. I'm going to run implementation. It's probably going to take a minute or so. Once it's ready, I'm going to do a create a bitstream file, and once I have that, I'm going to upload it onto the board. And you have already seen the demo, but I'll just do it one more time. Now that the bitstream file is complete, make sure at this point your FPGA board is connected to your PC. Click on Open Target. At this point, I think I have it already plugged in. I'm just going to simply just program device over here, select my chip right here. It's going to open a dialog box. I already have my bit file uploaded. Click on program, and that's pretty much it. You should be able to see the implementation of your code and design onto FPGA board. I hope you enjoyed this video. Hoping that you will find it useful and you can use this for any of your digital electronics project. If you haven't already, please subscribe to the channel. What they should do, Aizal? They should subscribe to the channel. Tell them to subscribe the channel.
Subscribe the channel.
Right now.
Right now.
Thank you, folks. Enjoy your rest of the day and stay safe. Bye.
Okay. I hear sound of my dad talking.